Whether you are preparing for a tech interview or just studying to be a better developer, mastering algorithms and data structures is essential. They don't just show up in whiteboard questions, they're the backbone of real world performance. In this video, I will show you how binary search works, one of the most classic and useful algorithms. Before we jump into code, let's talk about why binary search is so powerful. Imagine you have a list with 1,000 items. A simple search, going one by one, could take up to 1,000 steps. That's O of n time. But using binary search, you only need 10 steps, because every time it cuts the list on half, and that's O of log n time. Think of it like guessing a number between 1 and 100. If I can only ask you yes or no questions like, is it greater than 50? I can find your number in 7 or less guesses. And that's binary search in action. Now, let's implement binary search using Go. The logic here follows the example of Grokking Algorithms book, but written in Golang. So, the first thing here is to read what the question is telling us. Given an array of int nums, which is sorted in ascending order, and an integer target, write a function to search target in nums. If target exists, then return its index. Otherwise, return -1. You must write an algorithm with O of log n runtime complexity. So the first thing that we can write here as a comment is that we must return a index if the number exists in the array. So what am I saying? Here on the first example, we are looking for the target 9, the number 9 on the array of -1, 0, 3, 5, 9, and 12. Okay, we should not say on the return, on the message return, okay, it exists. It's not a boolean case here, or like in how many guesses or how many steps we find the number 9 on the array. And on the example 2, the target is 2, but there's no target here. So what should we return to the function? It is -1, saying that there's no 2 here. So we are going to return -1. Why? Because it is impossible we have an array or a slice with -1 length. So in the code, we could also comment that if the number doesn't exist on the array, we should return -1. And how can we do this? Okay, the first thing that we could do is to return -1 as a default condition here. If the loop return none, we are going to return to our function -1. Okay, so the binary search can work. We have to establish the two main characters of our function. That is coming to be 2 pointers actually. One is low, receiving 0, that's the index 0, okay? And the second one is high, as the length of the array -1. And here is the core of binary search. This for loop is what makes it efficient. We calculate the middle index as mid, being the average between low and high, of course divided by 2. And this is the element we are going to guess. And so the loop can work, we have to grab our guess value as the index of mid on the array, okay? And that's our current guess. And if our guess is exactly the number we're looking for, we return this index that is of course in mid. And if our guess is too high, that means that our target is in the left half of the array. So we have to declare high as mid -1, okay? Otherwise, if our guess is too low, so that means that the target that we're looking for is on the right half of the array. So we have to declare low as mid plus 1, of course. So what's happening here is we are shrinking the search space by half each time until we either find the target or run out of elements. And that's the magic of binary search. So, if you're studying algorithms, I highly recommend you the book Grokking Algorithms. It's super beginner friendly, uses visuals, and explains each concept in a way that actually sticks. Also, if you're into content like this in Portuguese, check out Augusto Galego on YouTube. He breaks down data structures in algorithms in an incredibly clear way. Definitely worth your time. If this video helped you, feel free to connect with me here on LinkedIn. I will be sharing more videos like this, especially focused on backend development and computer science fundamentals. See you in the next one.